discussions on sustainability and track. That's not right again. Within track, probably for now a couple of years. Previously, I was within technical authority, where we kicked off the sort of low carbon track sustainability work that you'll see here. We then pushed it into supply chain operations. So I work for Route Services supply chain, and I look after sleepers, ballast, rail, and now bits of S&C, not all of it, but bits of S&C, some of the composite bearers and crossings and so on as well. Alongside my fellow principal engineer, Ian Bostock, some of you may know. So I'm going to talk mainly about sleepers and ballast. Although we've captured everything, we've got rail as well. Sleepers and ballast are sort of main areas that we've been focusing on that we can make a change on over sort of, the next 2 or 3 years. So we'll talk about the decision to cease hardwood for composites, recycled plastic. It's on new sleeper development, what we're doing with concrete, what we're doing with some composite sleepers as well. The life cycle carbon reduction sleepers, so how we got there, how we reduced the carbon to where we are now. A little bit of lateral resistance testing about USPs, LERPs, and the testing we've done. I know Andy's been speaking on that on your sort of track buckling discussions as well. And a bit on recycled blended ballast, now called reused ballast, because that's not the right term in sustainability terms that should be used. So you'll see that later. So back in May 23, June 23, we ceased, 24, we ceased the supply of hardwood tropical hardwood sleepers from Brazil. So we were actually procuring sleepers from Brazil. And the main reason is the deforestation issues, the issues we were getting with surety of supply. We couldn't get surety of the FSC qualifications as well. And also we noticed this sway towards other products. So we knew that plastic was an alternative. People were looking at using composite sleepers. And then the sustainability team was sort of questioning, actually, if we've got something that's circular, recyclable, reusable, why aren't we still buying timber? So this is just for sleepers. It's not for S&C bearers. It's just for sleepers. So we ceased procurement in June. Those previously ordered could still be installed. So if you've got a pilot somewhere, you can still install them to something stockpiled for 6 months, as you would do, And some suppliers actually said, here's some on the black market if you want. So there are ways around this, but we don't condone that. Our main drive, we went to executive leadership team boards. So Andrew Haynes was on the board, Martin Frobisher, head of Technical Authority Engineering was there, and all of them, and the head of sustainability all said, yes, we must do this. This is what we have to do. There was a slight cost increase, about 15% cost increase. So that hurt a lot of people. But a lot of people also said, we've got to do it. We've got to make that change. We've got to, commit to zero carbon and so on. So that did go through. We put use cases together. We put a lot of justification why we're doing it. S&C hardwood bearers are still available. Adjustment switch is still available for gathering panels and all the other weird and quirky stuff that you do other than sleepers. So in between S&C and sleepers. We haven't changed our TRK 2102, which is the sort of track design construction standards that we all go to when we do renewals. That still says timber, doesn't say you can't use it. It still has the restrictions where you do use it on category 1s and 2 tracks and stuff. And we did make some emergency stock available because there are some cases out there where actually, there is no alternative. Here you go, here's some stock. So that's gone through, and just a little bit of the summary of the impact. It's 83% less CO2, 100% longer life, so they last longer in the track. We're reducing deforestation. At the time, it was COP26, where we sort of committed that we weren't buying the Brazil deforestation issues that we're going through, and to reverse deforestation, we weren't helping. So we had to put a stop to that. Huge whole life cost savings. The recycled material was actually UK plastic waste, so it's being developed from UK plastic waste, actually somewhere near Middlesbrough. Used to be North Wales, but now it's Middlesbrough. And it goes back into the sleeper, so it's circular economy. They're fully recyclable at the end of life, so you can melt them down at the end of their life. Quality of supplies assured to a higher spec compared to hardwood. We had hardwood was coming as variable supply. Some were so green, they'd only last 10 years. Some would shake, some would crack quite easily. So that's another reason why we went for something else. Higher social value. This is UK supply, UK trade, rather than getting in a sleeper from somewhere else, in the world. Couple of photos. So this is, I think it's Lambista. Yeah, North Wales. Central, yeah. Hereford DU. Hereford DU.
Yeah.
Manages. Yeah, yeah. So this is one of the first spot sleeper sites. You can see it's an amazing site. Lovely ballast. Yeah. I think the mud's holding it together. So, so this was really a test because it was like, well, you can put timber back in there, but you probably need something that's going to last a bit longer to hold that, to skeletise the track for the future. So this was a 1 in 3 spot sleeper that they did. It's one of our first ones we did with a few, some other areas as well. But this one was quite a successful one. And it just proved that you do it the same as you do it with timber. So there was no difference there. They used the same methods. I think they drilled one side was pre-drilled, then they drilled the other one side, chairs in. Working with bullet is a little bit funnier because you can't put the sleeper underneath, as you know. You have to twist the chairs because the jaw has to go around bullet. So that's one thing people forget on bullhead. But so track refurbishment, no change there. This was a guardrail site at Shrewsbury. This was over a viaduct. It's one of our guardrail sites where they would have normally used timber. So instead we used the 56 VS base plates, vertical base plates for the guardrail, and I think they were on the outside. We've done a mixture of different base plates for the outside, some of them combi base plates, some of them fast fit base plate, but fast fit base plate as well. So that was one of our first trial sites that we actually monitored as well. Monitored to see, gauge, was there any expansion, contraction, because it's plastic. It's got a higher coefficient of expansion than steel, so will it expand once or contract once it's installed? We had all the answers to this, but we need to see it in the track, all rotate burst around to see if it was a problem. Luckily it wasn't. And check rail sleepers. So some projects that are having panels prefabricated check rail, same thing. It does exactly as the timber does. Any base plate that can go on timber can go on this. Only difference is you can't put the spike chairs, the BR1 spike chairs with the rail spikes. So which has caused a bit of concern for a few people because there's still a lot out there.
Well, I thought we stopped using spikes.
Sort of, yeah. So what we sort of thought, well, maybe that will push us going away from spikes. We couldn't make them obsolete. We wanted to, but by doing this, sort of does push that. Because the spike in timber, it's sort of just found its way in, but with plastic, it's different. It doesn't have the same friction. So even though in the States they use these with spikes, and they still use them with spikes, so it's just something that we didn't really want to continue going forward. Some more guardrail sleepers there. That's with the fast fit base plates. So they were developed for side cut sleepers as well. So it does exactly the same as G44, the furnishings and jewellery as we call it. And we did an adjustment switch at Shiplake, on the Henley on Thames branch. So that was done, I think, by Colas last year. Is that Barnford Tunnel? I think it might be. I think Sean Hodges or someone from Colas gave me that one. Yeah, I think it's Barnford Tunnel. And this was one thing that people were looking for a low cost solution. And one of the sites on Western's going to be installed with this. So they're MOW clips. So instead of spiking guardrail, the old way used to be an AS screw just sort of spiked every other one. You can see on some RPW drawings. So I said that's not good. You can't rely on the sort of overhang of the head of an AS screw to hold down that rail. So, I mean, lots of people have seen these clips before. We use other things, so we just said, why not use the MOW, clips for that reason? And that's a low-cost alternative rather than using the base plate. You're not expecting to have anything on the rail. It's to guide it once it's derailed, so it's doing its purpose. We also issued some guidance on the use. We did a guidance document, and I think it was just, what can you do with a composite? Is it the same as hardwood or softwood? Can we use it in the same ways? What are the depths? So there's 132, 252 depth. The width is 252, but there are 300 wide if you want to go slightly wide on certain check chairs, or if you want a wider sort of footing for a base plate. We can cut them down 250 off the end. So we looked at one project which was a tunnel in the Kensal Green, and it had the old DC lines at Kensal Green and a very tight invert. You could only fit in a 1950 sleeper, 1950 millimeters long sleeper with beveled edges. So we made that work in that tunnel. The job got cancelled because of other reasons, but we had a sleeper that was, ready to be used in those tunnel works. All base plate types work, all screw types work. Rail spikes, so as I said, not permitted to be used. And they're very similar to timber, 840, a bit lighter than timber, because most timber is like about 900, 950, especially like a Jarrah, which is even above 1,000 a lot. And when they're wet as well, they weigh a lot more than that, so it's slightly lighter. But you know what they're going to weigh, that's the good thing. Where we've got weight restricted, depth restricted, or even length restricted digs, installations, viaducts and stuff, then they're ideal for that, like timber was. But you can go a lot closer with this than timber, because timber would split if you go within a 50 mil or 100 mil of the chair screw, you'd get split straight away. So with these, you don't get split. So they're a lot more usable in that sense. So a couple of more plastic sleepers and composite sleepers. This is the, if you've heard of it, the Hedgehog. So the Lankhorst integrated composite sleeper. If you went to Rail Live, anyone this year saw this on the Network Rail, Southern Rail Systems Alliance stand. So Nick Matthews, if you guys know Nick. So Nick and I were we kicked this off, but sort of left it to Nick now to manage. But it's based on a sleeper that has integrated housings. So the housings, instead of being on a base plate, you screw down, you take away the steel, the base plate, steel for the screws, there's a lot of steel there. So it's a lower carbon alternative. There's a lot less plastic there. There is some reinforcing through there, but still the carbon for this sleeper is half that of a concrete sleeper.
It's only 25. Getting recycled plastic.
That's recycled plastic, yeah. The only problem is that's made in the Netherlands, so it's not UK. It's made in the Netherlands, so we use it there plastic. Yeah. And then the company makes steel wire and they coat it with plastic, so it's their steel that they use for steel wire, bulked up for reinforcing, and then still they've got plastic moldability. This is one of their early sleepers they had. That's about 5, 6, maybe 7 or 8 years now. So that's their first Type 102 that they did. And you can see it's designed to wrap in the ballast. Ballast wraps around it. It's got high lateral resistance. I think at this stage now they're looking for some trial sites to be able to buy them for the trial sites. There is some funding available though. So yeah, the idea behind it's got integrated fastening, so it's hand roll FD or FC, so they're passed into the plastic. Increased lateral stability, though it's outperforms G44 normal sleeper. It's very similar to a G44 with LERPs in terms of lateral resistance. It reduces ballast maintenance. So yeah, some of these things need to be proven. So once we get it in track, we can see how it tamps, how it performs, how it settles as well. Because underside you've got some hollow points, so the ballast sort of beds in underside as well. But we need to understand, will it settle? Will it start to sink? Will it go somewhere else? You don't know. So those things that we need to understand. 60% reduction of embedded CO2 is based on the old concrete prices. Now concrete CO2 is now 50%.
Apologies for the lateness.
Don't worry, there is some chair here. If you want this one, I'm not sitting down for about an hour. Maybe half.
Thank you very much. Yeah.
And it's also got third and fourth rail, so we can get the third rail on. And in the fourth foot, you've got fourth rail holes as well, so that you can mount a sign or a fourth rail. And that's the drawing there. So if you flip it on its back, you can see it's got holes hollow underneath as well. You've got 4 reinforcing rods going down the side through the sleeper as well. So when you to recycle that, you melt it down, you take the steel out, recycle the steel, recycle the plastic, and put it back in the process again. So very elaborate, space age.
That's what was happening in practice, wasn't it? I assume a lot of sleepers would go back, depending on the lifespan of them.
All depends on the logistics.
Yeah.
Yeah. So what we haven't tested yet is with all of these recycled products, is how we have the logistics to take them from where they are. We have to put them in the contracts. We have to make sure that anyone that's taken them out, take them back to a certain area, we have to pick them up. It's like recycling pads and nylons and those things. We don't have the logistics that's never going to happen. So we have to build that into future contracts to say that thou will take any sleep that can be recycled. Now in the future we're going to be doing the same concrete slips, crushing them, using the aggregates, using the steel, using those sort of things. So we need it, and we need the same for Ray as well. We need that better circularity. But cascading, there's no reason why you might take that sleeper out. There's nothing wrong with it. You're just changing it for some other reason. No reason why you're doing the renewal, but cascading, we use it. Is obviously the first option that we like, but you're absolutely right. You need to have the whole logistics process in place to do the recycling. At the moment, if on composite sleepers, if they have a failure in the plant or a rejection, they just put it back through the system. It just gets mashed up into granular bits and it just goes back through. So, which is good. With concrete, it's a bit different. So there's still other examples of integrated composite sleepers, bearers. This one here is the engineered polymer sleeper from Voslo. This was in a trans this year. They've I think about the last 2 or 3 years they've been developing this. It's got some Deutsche Bahn testing it as well. So again, integrated housings, fast clip housings. It's a far different material. This has sand and plastic, so slightly heavier and slightly denser. So a lot different from a recycled plastic. It does have recycled plastic in it. So what we're sort of thinking is how would we use that? Because we're sort of in this mentality of we know what concrete sleeper does, we know what timber sleeper does. If composite replaces timber, that's good, but it's somewhere in between. So it's it's still, I guess, to be debated where we would use that. And that's the SciCut recycled plastic integrated sleeper. They're still testing it. That's obviously level vertical. They need an inclined version of that. They're still testing it, doing the ear testing for fastenings and so on. The problem with plastics, as opposed to concrete, is that you can get creep in the plastic. You can get movement. With concrete, it just cracks. You see it, it's cracked, it's broken, it's gone. But with plastic, it deforms in a way. If you can't see that deformation or measure that deformation, then that's an unknown. So they're the sort of things we have to look for. But that's, yeah. So how this actually worked was we did a remit and we had some funding to do the integrated composite sleeper, and then the other suppliers started going, oh, that sounds like a good idea. We'd like to join you, but they did it on their own back. So a lot of these other guys did it on it. And a lot of other suppliers do the same as well. Find it.
So us suppliers putting their money where their mouth is, as it were.
Yeah, that's right. Yeah, otherwise, we can't pay for the development for everyone.
Yeah.
But it's more. There is a need, and so it's a nudge to the market basically. So we've also been playing with Cemex, or Cemex have been playing, but we've been saying to Cemex, right, we need to find an alternative G44 or EG47 that has ballast locking, lighter weight, smaller, cost less as well. So we're looking for a cost reduction. And these are some of the prototypes that they've started to look at. We've sent them to Southampton to do some lateral resistance testing in a ballast box to see how good they are at resisting, the lateral forces. So it's still at that early days, and we're still waiting for the results to come from Southampton. Also doing some other things with different concrete mixes. We're looking at fibre reinforcement, recycled aggregates, though that one's sort of on pause, but certainly when we recycle ballast, we use ballast and we take out the aggregates from that. Can we reuse them in sleepers? Making sure there's no other impurities in there, like that would start alkali silica reactions or anything like that. So you got to look at those other things. Recycling the housings or reusing them if they're still intact. Reuse the housings because there's quite a lot of steel there as well. They don't tend to get that worn, but they do get damaged a lot. Certainly not reusing them. So anything we could do. And there's also a big cascade project. I don't know if Western's on looking at the cascading. I know that a lot of other regions are starting to, or not a lot of them, but some of the other regions are starting to look at how they can assess the serviceability of all their sleepers so they can reuse them. We always used to do that. We always used to save sleepers back, didn't we, from trap renewals, reuse them, put them down in the other lines. But it seems like over the last 20 years that's stopped, but we're now sort of promoting it, saying,
Yeah.
please do it.
I think back to what you were saying earlier about supply chain. I mean,
Yeah.
it worked well at one time because we had the vehicles, the people, and everything else to make it.
When we were one integrated,
Well,
happy family.
Yeah.
Yeah, that's right. We're all doing this similar thing, but that obviously changed. Some of this, or most of this work has been put into a new specification for sleepers. So when we want to purchase, specify, test, trial new sleepers, whether it's steel, plastic, concrete, then this specification here deals with the whole range of what you'd want from a business user perspective, from a engineering and mechanical performance, all those things within that standard. And it reaches out to all the other standards as well, the concretes, the timbers, the steel standards as well. So it talks about circularity and low carbon and having a sleeper that's got high lateral resistance and works rather than just a lump of concrete that we've known and loved for the last 50, 60, 70 years of concrete nowadays. It's sort of basically saying if you were to redesign this with a new sleeper technology, this is what you would do, this is how you would do it. I don't know if anyone's seen this sleeper guidance document. That's been issued as well. Just gives you a general idea about the different types of sleepers we have, what they do. We're going to try and keep it updated every 6 months. Quite a few comments, things we can update, all the different sleeper types and uses as well. One important, well not important, but one useful part of that is this life cycle assessment tool that we included. So it lists all the different sleeper types, all the concrete G44s, G47s with all their USPs, serviceable grade. So this is our serviceable sleepers as well. And then steels and also plastic and FFU as well. So it lists those. Timber used to be on there, but now it's gone. We've sort of removed it from the list. It's on an old list, but not on this list. And we've got the latest prices, the trap renewal rates, the whole life cost per year. And then we look at the average tonnage, what it's designed to be used for, and based over that sort of duty cycle, how long it would last. And you can calculate that from its design life. It tells you how long it will last in certain applications. And in fact, I think I actually shared this with TFW as well to look at some steel and concrete and plastic variations of what they might do on TFW, so they can see, what is the best solution. Just by changing that tonnage, the TFW chat, we put the TFW tonnages in there like 15, 16 million tons. Let's sort of see which works best for each area. And so through the lateral resistance testing, we're able to give that a scoring as well: high, medium, low. High meaning yes, it's very good at resisting lateral forces. Low being it's probably one of the, not the worst ones, but you can see EG47s on there. That's concrete, but actually it's quite low. Similar to some of the I think the composite without base plate, but with base plates and FFU then low as well. So it's timber's low. Then you go up to the medium. So steel is actually better than an EG47, believe it or not. I know we say it's not, but we've tested it. British Steel have tested it, and they've also confirmed the same as well. Oh, that's smart screen. And the important bit was the USPs. Everyone was asking how much more is a USP pad. I've got some examples of some unseen pads we want to pass them around if you want to. What does a USP add to that in terms of performance, in terms of cost, in terms of life? So we added that in there as well, so people can sort of see.
Yeah, because there's a lot of rumour going around, isn't there, about likes of
Minimum viable product. Yeah. Yes, there's lots of rumours and the talk at the moment is that actually USPs are as good as they say they are supposed to be. Then why don't we mandate them? That's one thing. But the category 1 and 2 it's actually an amber clause at the moment, so it needs to be derogated at root level. So if you don't use a USP on Cat 1 or 2, you need to derogate it. So, and that could change. So there's lots of work to be done to prove the evidence on that. And there's about 16 different riders and things in there just to explain. It's not for this, it's not for that, it's not for that. It's not. This is whole track cost, whole life cost per year, installation unit rate. So it explains how to use the table as well. And right on the far side, we've got the whole life carbon. So we've got carbon per sleeper, so 54, 57, 56. Some of those are reduced, so we're going to put a new table in for those new rates. And we put for the serviceable grades there, we put in 5 because we know it's done its life. It's out, it's done its life, it's now gone back in. So we're taking a sleeper that someone's already accounted the carbon for and we're reusing it. Now we've spoken to the sustainability and what way to do this? That's not the only way to do it.
So it's like a carbon depreciation.
Yeah. Because and so we put a figure in as 5, and we said we call it 5. It might not be 5, but we know the carbon's already sunk because we'll be using it. Yeah, so it could be 6, it could be 7, it could be 8. But we've given that figure just to show, well, it's not new. We're not, finding resources and it's not new ballast instead. It's already sunk. That carbon's been sunk. So, because when you use recycled plastic, they do the same thing. That's reused plastic. So, okay, there's enough on that table. With all the carbon figures that we've been producing and all the different sleepers, we then sort of looked at how much saving over between 2022 when this work started. So coming up sort of towards year 4 of CP6, year 3 and 4 CP6 when we started this work. So we've got the carbon, we've got hardwood still in there as well, but the steel figures, the concrete figures, the composite. So that's what they were in 2022. 2025 they changed to this. Hardwood obviously didn't change. Steel went down. They started to come up with better production rates, and they're still to give us a full CPD for that figure. Concrete is sitting out right this moment in time. The concrete is at 52 and composite is at 34. So that's gone even lower down as well. So that overall saving is, in fact, the overall saving, that 47% is wrong, it's 53% saving that we have compared to 2022. And we also aggregated CP6 CO2 versus what we're now going to have as an average of CP7 as well to show that. And it's around the 53% mark. So we're basically half the carbon in. And you see there the hardwood has basically gone down because we're now procuring hardwood and procuring composites. The composites gone up in volume. We've kept the same volumes, even though volumes for CP7 are down because of mules are down and spend is down. Generally the volumes have gone down about 25% in most of those areas. But we kept the volumes the same just to show everyone comparing eggs with eggs, apples with apples. Whilst doing a lot of this work, we were querying the lateral resistance issues with sleepers and what sleeper is best and why do we use LERPs still and why are we putting so many LERPs in and how much LERPs cost to install. I think Brian Painter and a few others, we were discussing this at the sleeper strategy group, and there was a picture that Brian, I think, supplied to us and said, I've just spent about $250,000 on LERPs, surely there's a way of saving that money. And we said, actually, yeah, there is a way. Do we really need that many LERPs? Because, let's understand how track buckling works. And is there something else we can use in that place? So we looked also at doing some testing with Southampton and to understand what LERPs add to your concrete sleeper. What does a LERP add in addition to a concrete sleeper? We also did some testing with the ballast profiles and all sorts of other things about some different sleeper types. So the ideal really is that we really need a sleeper that is future resilient because obviously temperatures are going up, track temperatures are going up. I know we've got our CRT up now, SFTs are up to 30 degrees. So that's a sign that we've had to do that. But we need sleepers that can, perform better than they used to. And decarbonising the track, so if we can reduce the CO2 by installing lerps and other things that we do, making track last longer and so on, then obviously that's the right thing to do. Unit rate cost reduction, so what, by not using lerps, we don't have a unit rate for lerps, but it just adds up. No one does because it's such an expensive thing, but it was certainly a driver that came out of the National Track Delivery Working Group that said, can we,
Yeah, they're very expensive to buy and they're expensive to install as well.
Yes. Yeah, they're more expensive than a sleeper. And it's double that for the price to install. You have to take them off into tap. Yeah.
Yeah, we did some work as part of the CASA project and we put in basically
Oh, yeah.
guide rails as well. So,
But yeah.
but obviously that's only a viable thing if you're in a new track.
It is a retrofit. I mean, you can't, we're sort of doing some testing with other sleeper pads and other things. You can't retrofit some of those things. So it's good. They're good for retrofit, but do we really need to put that many in? So we went to University of Southampton because they had the ability to do some testing with their rigs. We built a ballast box, we put the sleeper in, we built a test spec to push all the different sleeper types through the ballast. We looked at different shoulder heights, level, up, down, and different bed heights as well. Compacted ballast, non-compacted ballast. And we did some testing with recycled ballast as well, but that's another thing we'll see later. But the results showed that a G44 without an undersleeper pad, so that's the blue line there at the bottom, sort of looking at about 8 kilonewtons-ish. And then once you add a USP to a G44, you're going up near the sort of the green mark, type 2 and type 1, so somewhere between the green and the black. So you almost add 50%. And it's very similar to the lerps. So the lerp with a lerp, that's sort of the amber yellow lines there. So again, very similar to what a lerp does in terms of lateral resistance because the USP is bedding into the ballast and it's got higher friction. When you lose that friction is voiding, then you won't have the lateral resistance. That's where lerps have an advantage because they're still bladed in, they're still holding. But generally, yeah, we got that much voided track that we were in. And we do have an allowance in sort of CRT mod 14 for voiding as well. So we looked at this, we said, well, can we consider some changes to TRK 2102 to relax lerp usage, where you use USPs instead? And the answer was, yeah, let's consider it, but let's do some more in-track testing. Let's test it in track, maybe with a dynamic track stabilizer and with tamping and look at sort of, pushing it in CWR in situ. So that's where we got to with that. Overall, all the sleepers, so timber, you can see right at the bottom there, about 4. You've got the G44s with USPs, lerps right at the top, around 12, 13. And we look at 3 things on this. We look at 3 reporting on this. So we look at the trigger, which is when it moves, the unhooking, if you like, that's at 3 millimeters. 2 millimeters the urinal, but we said 3 is 2. You just can't measure 2, but 3 you can. So we went for 3. And then we look at an average, and then we look at this. So the average over, I think, is between 25 and 30. The average there, when it's becoming a derailment risk, and then we look at the highest one as well. So we look at those sort of 3 trigger values. So see there, 3 mil average load, 25 to 30, and the maximum horizontal load. And you can see there, these are the comparisons. And EG47 is quite low. EG47, which is the without a USP, the red one, yeah. So sort of in that band there, which isn't great. And it just goes to show that we don't have any difference between concrete sleepers, EG46 and G44s in our
Concrete.
they're assuming concrete, yeah. When really it's more near timber than it is E44, so that's got a few people thinking. And actually, steel sleepers aren't as bad as we used to. We said we had to put strengthening around steel sleepers, had to widen the shoulder of steel sleepers when I don't think we do. And that is based a lot, that is on the previous issues we had with the older type.
The lightweight.
Yeah, the lightweight.
Lightweight.
Yeah. As soon as we got the spade ends, the deeper ends, and British Steel are actually now looking at developing even other things on the rails and to make them even more lateral resistance, but with bars and stuff. So they're trying to sort of improve on that as well. So yeah, this was the finals with EG47. So you can just see that with an EG47, it's doubling it. You know, it brings an EG47 some way above a G44 with the USP. But we just had to sort of prove the point that actually we are not far off that what Alert can produce. And the EG47 says that should be installed on split pads to actually match what G44 does. If we were saying actually the G44 is our bench line, then we need to have USPs and all our EG47s to meet what G44 is. So that's sleepers. That's sleepers tested. Sleeper testing. We did a bit more testing with Southampton on this. So this was an initiative to recycle now termed reused ballast. This was started around 5 years ago, maybe even longer than that, and was by one of the persons, Andy Bayliss. He's from the quality team. He's doing a lot of auditing. He's ex-Cemex and does a lot of audits on the ballast suppliers. And the whole purpose here is getting spoil from the ground, trap mules, bringing it back into this plant here, and mechanically cleaning it, washing it, sieving it, washing it again, mixing it with new ballast, and then we've got a reused ballast. And the plan is that all future ballast, you won't be able to buy reused ballast or new ballast. It's just a mix. So from now on, all ballast will be a mixture of reused and new. We're not going to have one bag of one bag of the other. It's going to be one blend, if you like. We've just got to see what type of blend. But this was as a result of the testing, which I'll go through in a minute. But some of the benefits of it were so current tests from several potential suppliers show that we've got 65%, circa 65% of spent ballast can be processed back into reused ballast. Some gave us 50, some gave us 75, so it's 65. One gave us 80. So it all depends on the source and how old the ballast is and how much spoil is in there, and I'll show you things as well. So I think we purchase around 1.2 million tons of ballast a year. It's about £20 a ton, so it's quite a lot of money. And that price is going up, and that's our price is going up as well. So we were looking at, can we have a saving? Is there a saving from this? But can we also, we're also running out of supply in the UK. I think they've said by 2050, 60, 70, we're going to start to see it. So we need to find an alternative supply. We're already buying from Norway. So we'll be bringing in from Norway. So this in the future, we don't need to buy from Norway. We can just use our own countries.
What's the cost of taking it back off site though, when they?
But so the cost is, it's going to get processed anyway. It goes back to the aggregate handling depots, the AHDs. So it goes to Westbury, is the nearest one here, isn't it? So it goes back to Westbury. There is a contract at the moment for someone to buy that. Well, they don't buy it; they take it away. Zero. They take it away. So they're doing away with our spoil. So that's non-contaminated as well. If contaminated, we need to pay people to take it away.
So this bit is reused, but
they do it. We don't. Yeah.
we don't get.
Yeah, we don't get the benefit. We don't get the profits or the benefits of it. So I think there is an agreement. It's something like £2 a ton. It's called product A or something. So there is a financial, but it's so small. It's for them to sort of take it off our hands. So the obvious things are it's reducing CO2. There's not a lot of CO2 in ballast.
Can I come back in there, Darren?
Yeah, go on. Yeah.
Going back 30 years,
Ballast cleaning.
ballast cleaning.
Yeah.
Spill to line side and chuck back what was riddled. as
Exactly that.
unsuitable.
Yeah.
Now,
50%.
what's the process today? Is it total recycle? Is it total excavation? Or spill and recover, spill back into track and recover?
So I was speaking to Joe Peter Flynn, who does the high output. So that's the new high output team. Average is 46% return. they get when they do high
At
output
like,
ballast. Maybe.
in line.
So that so they say it's around 50%, 46 is what it's sitting at. So they're feeding 50% U. So they've got 50% U on the train, and the 50% that comes out goes back into the spoil wagons for the side, but it's 50-50.
And then the reuse at 50%.
Yeah. We're getting higher than that because they question why have you got higher? So, well, because we've got a different mechanised system that washes a lot better, sieves a lot better. It's a bit than what you have on the train, which is a bit of a smaller bit of kit. So we can get.
What about the size? Is this smaller?
So I'll show you actually. Got a video.
Right, okay.
Got a video. Yeah.
Oh,
Well,
okay.
it's a lot bigger. If you look at it on a piece of ground, it's a lot bigger. Yeah. But you can. So see this machine here. You can put them in certain yards, and it sort of spiders out. It can do it. Do the same thing as a ballast cleaner. But our plant is a permanent sort of fixed piece of plant. But there is transportable pieces that do the same thing as a ballast cleaner does.
So if you had a blockade or something, it might be worth considering doing something.
Absolutely. Each region could buy their own, but that is the thing. But we need to make this logistically network wide, because at the moment it's only available in Stoke and Crewe, but the plan is to sort of widen it out. So it's most of this is about depletion of natural resources. CO2 is the same. It's not a bad saving, but it's because we're running out of ballast, we're quarrying, so biodiversity and these things are coming.
To that respect, reduction in handling. I mean, if you go start bringing in rock from Norway, that
Yeah, by boat, yeah, it's not good, yeah. Other sort of byproducts from it are for sand blankets, or for construction. We've got some smaller aggregates. Someone did ask me, and I don't. I think it was about use in chippings for stone blowers. We consider it, but we just don't get that return, and it's a different consistency of that material. It is a bit unsure, so we've decided to just stay with 25mm stone chippings for stone blowers. So before this was all approved, we had to look at what are the disbenefits, what are the risks of using it. Even though we've been ballast cleaning for 50 years and we've been doing sort of cylinder return, no one's really noticed the track moving or things happening with the ballast cleaning, not like the drainage isn't working or anything. So we had that to back it up. We had other countries that said we've been doing it since 2016, 2017. So Norway are doing it, France have started doing it, SNC have just started last year. So a lot of people are doing it. A lot of people are sort of starting to use it. But we looked at sort of what you would expect from ballast, so the quality, consistency of the material, impurities, angularity. Everyone should say you can't use ballast because all the angular bits are just knocked off and it's going to lock together, which is, those pieces knock off after the second tamp, third tamp. So they're gone within the first 3 years. So they're only there at the start. And it's work hardening itself, knocking off the corners, and that's when you start to see more settlement as those pieces go. And what you've got with reused ballast is a work hardened piece of ballast that's had all the soft bits knocked off, so it's not going to break down anymore, so you get less fines. And you've actually got better contact surface because you haven't got the angular bits that are sort of digging in. You've got surface to surface. There's a higher surface, higher friction, and Southampton University have proved this with lots of, they've done a paper on it back in 2016, 17, to sort of prove those theories, and they did a lot of testing. So that's why we use Southampton, because they did a lot of that testing in the first place. Someone actually said to me, why did you bother going for that? In fact, some of the regional engineers said, yeah, well, surely just a couple of tests will prove it. I said, well, no, we need to make sure if we're going down this route that we're doing the right thing. It's fit. So ballast migration, we're going to start using ballast to reduced vertical and natural stability. Organic content was one. What about if we get lots of twigs and other organic content in there that we get from spoil? How much is an allowable organic content? And then also there's lots of limestone out there, so we're still seeing about 5% limestone coming back through from old digs, and it's still there. So is that going to be a problem mixing limestone with granite? So we explored those as well. Back to Southampton, coming quite a popular trip there was. Back in the lab with some, this time with recycled ballast. So we had recycled ballast, new ballast, and we even had a synthetic ballast, which is It mimicked worn ballast that was about 25 years old, lots of fines in it, so on, just to see actually what does track look like once it's had more ballast? Is it better than new ballast? So to understand that. But this is really to prove that the recyclable or reused ballast is as good as new ballast. That's the point of doing this. So again, pushing the sleepers through the with the ram through the ballast. We got very similar, slightly better. So fresh and black, somewhere in the middle. Fresh is new. Recycled is the red line, so it's slightly better. And the green is the synthetic, which is supposed to mimic worn old ballast. And that's loose, that's not dense. So that's still loose with no compaction. We did the same thing with compacting as well, because we wanted to see what settlement does to lateral stability as well, how much it changes. And you see if you sort of flick between the two, it's slightly more at the end. Doesn't but we were only vibrating it to a million tons. So we're good. But that's what when we have a million tons, we can sort of start to play with CRTs then. So it proved to us that recycled ballast was as good as new ballast. So that proved that theory. We then had to go into all of the other physical and tests that you would do with minerals. So we did some triaxial tests. So this is a piece of kit. You put the ballast in, and it's loading it's a dynamic vertical load, so it's vibrating the top. And as that load starts to push down, it measures the strength it needs to retain the column. So the lateral strength it needs to retain that shape. So it gives the sort of displacement, the total displacement. So it's 600 mil. It's about, I don't know, a meter tall column that's being vibrated. I think we vibrated at about 500,000 cycles. And the outputs of that, I don't know if we've got the results for that. Did I click? No. But the outputs of that go back to that one, sorry. This is just delaying a little bit. The outputs showed that this was as good as new ballast as well. In fact, slightly denser because it compacted more.
Yeah.
And it didn't have the angular bits that were holding voids. So it was compacting and finding itself in a tighter spot. That does mean you've got less voids. That means it's not as good at draining, but it's 3 or 4% more denser. So we're reducing the voiding for porosity and for draining by 4%. But we also looked at how much fines come from new ballast as well, which started to clog up ballast. So it's sort of balanced out on the size. This is a particle size distribution. So this is our typical sieve sizes that we have in our standard 8100, and the black line is the sort of upper and lower control lines. So you see fresh ballast is bang in the middle of that, just at the top anyway. And as the recycled ones, the reused ones tend to go on the sort of smaller size, then come in. This is testing they did that went through the sieves from another supplier, so they did sort of an independent PSD test just to see how far off they are. You see what we did, we blended 100% recycled up to 100% new. So we did that 50-50, 25-75. So as we went down to 25%, we got within that PSD. But we also queried, is that the right figure? Is that actually giving us optimum ballast performance? And we spoke with Southampton, and Southampton says, no, we've done some testing with ballast that's more on that size scale or PSD scale than new ballast, and it's better, and it does these things. So it's like, what you really want to do is change the standard. But EN norms, and it's based on Euro norm for ballast. So you wouldn't go changing those things, but we just proved that actually we're not far off. And by mixing it 25%, 75% new, we can actually get it within that PSD range anyway. So that seemed to be the optimum. 25% reuse versus 75% new was the best sort of optimum blend that we thought we could use. And also the feedstock, we can't get all that ballast and just do a 50-50 because the feedstock isn't there. Did some mineralogy tests, looked at the sort of granite, basalt, limestone, flint, and all the other things that would be in a typical mix. We sort of sliced samples and worked out the mineralogy just to see if we are importing anything in there we don't know. And there you go, got 9% limestone in there. Granite's the main part. We did have some basalt in there. Some countries use basalt as ballast. We don't, but a lot of countries in Europe do. So we're looking at that sort of mineralogy, range. We did a process flow chart to show how it works. I won't go into it. But what this will do in the future, we have a lot of hazardous waste. At the moment, we just have to sort of sell, pay for it to be removed. But we're looking at how we can use hazardous waste through the same process and make some money out of it, and save some money from having to get someone to take it away from us as well. So that's the next thing to do. Now there is a video. No, it's not this last one, it's the next one. So just a bit of a summary on the approval and how we got there. So we showed the lateral resistance tests are as good, no worse than you. The ballast consolidation showed the stiffness and springiness is no worse. Triaxial tests on the different blends demonstrated strength and settlement are no worse. All these were slightly better, but we just said no worse. Abrasion tests, we did some abrasion tests, the blended better, they're actually better than new ballast, quite considerably on the abrasion tests, because they've been work hardened, because they're bits of lumps of rock that have stood the test of time. Got this to be approved in May, got one supplier on, we're looking for 2 to come along, and we're updating TRK 100 standard at the moment as well. So we went from a maximum of 75% recycled, so that's where we capped it. So we spoke with the head of track and we said, look, we're not going to go 100% recycled because that's a little bit, we're not sure where that's going to go. Let's cap it to say at least we have some new ballast in there. So we capped it at 75 recycled, 25% new. And the QA process was really, really keen. Well, it's really important we get the QA process right. We're having issues with our current ballast suppliers with dust and flakiness and those sort of issues. So we're going to update TRK 100 to improve that, but also make sure the QA processes are ingrained in there, because at the moment we're following them, but we just don't use the data good enough. So here's the video. I'm not sure, I don't think the following will work, but I'll be a bit stuck with it. Yeah, it should move it. I'm catching up. Yes, land recovery, Longport, Chemical Lane.
The street has quite a good position.
Right, it's not that, yeah. It does miss out south. Yeah, it's mainly, it's fairly close. You see the size of the equipment.
Well,
It's also to get the capacity. If you want to get 20,000, 30,000 tons a week, you need that sort of size.
yeah, I guess the only challenge is going to be you've only got so much ballast out to track it in one time.
Yeah, yeah. And not all of the challenges be there, we still need to know the HDs. So we haven't an HD yet. So this final cake product here, they're also looking for uses of that. It's very sedimentary, it could be halfway infill. But I like it to TNT. They've got all sorts of magnets and filters and other things for getting all of the other weird bits like pads and addicts. They'll fall through. They're looking at sort of infrared density sensors to sort of pick up some of those bits as well. There you go, off to use application. There we go, it's not blending. So 1 to 1, yeah, 2 by 1. Now it goes for a second. So that's removing any lines that might come across from the new ballast unit in the old
Yes.
one.
That's the other material.
Yes, yeah. Okay, so to try and get this fully implemented, we came up with this plan. It's for suppliers to provide a better way of detecting impurities, infrared or pattern recognition or density. So they're all looking at better ways to make sure impurities don't get in there. Our QA team are going to provide regular monitoring, so they're out there at the moment monitoring the blended ballast. The logistics plan for at least 3 HDs for national coverage, so that we get better spread. Unit rate cost is, so the cost, there is a saving. It's expected that as it gets wider and we get more transportation logistics in place, it will go down even further. At the moment, it's about a saving of around, I think it's around 20% saving, 25% saving, about £5-6 a tonne saving. But it changes. It all depends about scalability and how we apply this. It will only be a single rate, so you won't get bags, you won't get you or whatever. It just will be ballast. And it's geared on optimising your blended ballast implementation. So with future suppliers, future ballast suppliers will be ensuring that they have the ability to do recycled ballast, and not just new ballast as well.
So from a maintenance point of view, your bad ballast.
You won't have any different.
You just get bad ballast.
You get ballast. You get exactly that, Andy. So we've got 6 other suppliers that we're gaining information from. Some of them are recycled, some of them are actual recyclers, if you like. Some do ballast and recycling. So the main players that you see around here, the aggregate suppliers that we're talking with as well. Spoken with ProRail, Holland, spoken with SNCF as well. Some of them have been doing it since 2015, SNCF since last year. And we're updating the A100 as well. So that's
On ProRail, the big driver there was the fact that they haven't got much decent rock in the country at all.
No, they're pretty locked in. That says
Or whatever.
Yeah. Some of those countries use basalt as well, which is good.
Yeah.
So that is it. Time almost.
Yeah.
So yeah, open to questions.
Right, sure. Have we got any questions online?
Not yet, no.
Okay. Right, so any questions from the room?
What's the predicted acid life for the ballast, the recycled ballast?
As the same as new ballast, no difference.
Okay.
So it's no different. So the strength testing we've done and the fact that it's been work hardened and that we're just using stone that is not going to break down anymore, it's expected to be the same. And we looked at what we did with ballast cleaning and we didn't see any degradation there either with ballast cleaning. Not that we had really good tangible evidence, test evidence. It was more, not anecdotal, but like when the test of time for
The problem with ballast cleaning as we did do it, there's no washing involved, was there? So
No,
if you had a lot of,
Yeah.
and this is one of the challenges now is because we've left a lot of it so long, there's a lot of cohesive material in it.
to get a good sieve supply, good return, you need the water to push it out to flush it off.
So if you try, and that's why on site,
Yeah.
you ain't gonna get the same performance. And I think the Germans have got their formation trays reuse the ballast, don't they? They wash it on the train and crush it small and then put it back into the sub-base.
Some people use it sub base,
Use air
Hmm?
instead of water.
I don't know.
You could, that water there, they do recirculate it. So they've got a filter system that just keeps going round and round. So they're not using a lot of water, they're recirculating their water. But yeah, it's a lot of sludge comes off it.
Andy, yeah, I noticed on the table about the life cycle, is it that the FFU sleepers,
Yes, second story FFU.
yeah, weren't
Yep.
weren't so
There's
weren't so
Start
good
with
in terms of. Am I wrong? Is that because of the production process in terms of the amount of CO2 over the lifespan, etc.?
So yeah, I'll explain a bit about composite sleepers. So I've got one here is a Pioneer one that uses recycled plastic as well. You use low density plastic and hemp and other things to bond it together. Plastic used is flax, leadership there. Plastic, we use recycled plastic there with some fillers and UV stabilizers to sort of blend it together. FFU is basically glue and fibers. So glass glue, like using glass fiber, but slightly. So it's not made from recycled material. It's all virgin material, so it's got quite a high. Doesn't mean to say it's bad, but it's got quite a high CO2, and people know this. So the things with composite sleepers, people think composite sleepers means recycled materials, but it's not for that.
No,
It is for some. It is for most.
just for that one.
You know, so, and I mean, this is probably the most highest performing composite material we've got, compared to most of them. It's most expensive. But in terms of performance, it does more than timber, and it doubles it in its yeah. In fact, we've got some trial sites for FFU. We're looking at trial sites for a bit, but we've got some trial sites for FFU on southern and eastern bearers, using bearers. And we're actually saying this should be used on bridges structures because it's not stiff. So you've got some resilience. You know, over the years, we've taken a lot of timber S&C out on bridges and plain line, but on bridges and structures, maybe Cardiff, Queen Street and Central, all those areas that have got under bridges and sewer and stuff. And we're putting really stiff track in, and it's falling apart. I don't know why, but you know, because the timber lasting. So we're sort of saying you should be thinking about this.
Yeah.
It's very similar to slightly more than concrete, but it's lighter and it gives you that resilience. You know, and then
by all accounts, it's going to give a very good life as well.
yeah, and the good thing is you can drill it, fix it, glue it. You know, with timber, you've got to get people in to do the coring. You know, the houses fall out, or just you know, and we don't really have that tool in our toolbox to go and fix concrete sleepers and concrete barriers, but we still know how to do. I think we do. Is that okay? Yeah, we still got the people around. I think to do repairs. We buy that as well, but you know, we you know, so at least it's more maintained.
I think the other thing which has struck me is when we originally started down the recycled plastic route, it was just as a replacement for a softwood sleeper or a hardwood sleeper. So they're in the same section of them. Yes, you can see the hedgehog sleeper is looking at using the material in a very different way, isn't it?
Yeah.
So it's actually treating it as an engineering material in its own right.
Yeah.
To use it that way, and I think that's the next. That's the
I mean,
way we're going now.
So we're looking at USPs on composite sleepers. You wouldn't think why do you need it on a very low stiff sleeper, but the reason why we're looking at USPs now is because then they give better lateral resistance as well. So like they do with concrete, because some sleepers are good because they have some dimples and they bed in ballast, but they're not that great. They're not as good as they reported to be. So they may need a USP to give that lateral resistance, to give that ballast contact.
Slippery when they're new, aren't they?
Yeah, yeah. And I mean, this is so Sana 1206, so it's 12 Newton millimeters. So that's for high attenuation noise and vibration structures. That's 377. A lot, you know, that's the thickest we've got and the stiffness we've got. But that still beds in to ballast, you know, a lot more concrete and steel does. So that's where we get the lateral resistance. And these are products, these are sort of elastic plastic products, and there are some we're looking at which are rubber products as well. So granular rubber, recycled granular rubber as well.
Like tyres.
Vulcanized tyres and all, conveyor belts and weird things to do.
Yeah. It's not getting rid of.
Yes, yeah.
Remember, there's also, it's not just about lateral stability of the undersleeper pads. We are talking about huge improvements in sleeper life. Track geometry, life should be a lot better. So there are lots of wins as well as the benefit of the.
There is, and although USPs have been around now for a good 20 years,
Yeah.
and they were approved about 2005, I think USPs were. On London Underground, we actually mandated them because we only get one chance to do a renewal, so why not put the best in? And we don't go access, so why not put the best in to make it last? You're in a tunnel, you're putting track in, you're balancing tunnel, and you've got noise and vibration issues as well because you're in a tunnel, so you're reducing that NV, bringing the noise and damping down, and at the same time you're reducing the ballast damage. So
I was fascinated with the Type 104 sleeper, the
yes,
composite molded sleeper that to me looks a business. The universal or the undersleeper pad is another component.
Yeah.
Have they been combined in a plastic sleeper, which then invites the question, are the sleeper pads they're not extruded apart from the FFU?
Yeah. Yeah,
Are they,
you're right,
are
that's
they,
extruded,
are they
yeah.
poured or are they molded, injection molded?
Yes, okay, yeah.
And are they're reinforced, you said as well, are they pre-stress reinforced?
Yeah.
Or are they, so they've done a long?
So pre-stress, but not long line, short tendon pre-stress.
Right.
So our new concrete sleepers that we give with Cemex, we've got two concretes. I'll explain the process.
Go back to
John plastics, right? So going back to composites. So a lot of so as you say, has protruded through fibres, mixed with urethane that's protruded through. If you want to put a USP on it, you glue it afterwards. It's glued afterwards.
so
Under the sleeper, it comes out as a sleeper, so it sort of gets glued on afterwards as a and yes, adding USPs to composite sleepers, we've proven that it does increase the lateral resistance, but you don't need it for stiffness or ballast protection because they're already quite low stiffness. So it's more, look, go back 2 years, people were saying, do you need to put an undersleeper pad on a composite sleeper? We would say no, until we started to do this. And now the suppliers are, so we're sort of saying to suppliers, if your sleeper isn't giving us the lateral resistance we need, you need to add something to it to give us the lateral resistance. And the answer is a USP.
can you do that with a injected plastic by putting that formulate that
Into
rippling
manufacturing process.
into the manufacturing process?
You can't at the moment
You could,
because it's additive manufacturing. So additive manufacturing, you've manufactured it, you have to add it after. Say you 3D printed a sleeper, you could then 3D print an undersleeper pad on top. So that's one way that maybe in the future we could be doing that. 3D printing plastic and then we 3D print the USB with a different material and it binds to it. So, but no one's doing that yet. But
Could you put a ripple effect on
Yeah.
an injected
you
plastic
could
sleeper,
finish, yes, you could, yes.
which would
Yeah.
get you 3/4 of the way there, which might be enough?
Yeah, and on some of the plastic sleepers we tested, and some of them you guys know the side-cut sleeper that's got dimples on the side. They've got another one that's got sawtooth edge that digs into the ballast more, which is an enhanced lateral resistance sleeper, which is very similar to an EG47 concrete sleeper in terms of lateral resistance. So by playing with the shapes, like we did with the hedgehog sleeper, taking bits out and creating more of a sort of shear faces to act against the ballast, then you can get that lateral resistance.
And that's where it's.
But the underside, we're a little bit, well, because we want to sort of settle the ballast, but even with a hollow hedgehog sleeper, that's still a bit, how's that going to settle in the ballast initially? Now, are we going to see some differential settlement? Like we used to with steel sleepers, I used to sort of dig in after a while. Some suppliers are looking at doing sort of other finishes, spraying them on, or doing something afterwards. But at the moment, it's quite basic. It's concrete sleeper, concrete's wet, and then we just put that on osmosis, cure it so that casts into the concrete sleeper. But with plastic, you can't do that because it's still cured in a mold. If you took out the mold, it would deform and just go, well, not deform, but you'd lose the shape of the gauge and everything. So once it's cooled down, you have to glue it on afterwards. Some people have even, so on Nexus, they have timber sleepers, timber bearers, and they nail USPs, barricades, into timber. Into the areas.
Snow tunnel as well.
Yeah, a lot of the old, and originally people used to sort of nail it. Yeah, rather than glue it. Yeah.
I think picking up what Darren said, we're working with some manufacturers to get very much that was a joint effort, and the guys up on the Central Wales are very much involved in testing it and that. But now we've got other manufacturers who are now saying, it just depends on the question you ask, isn't it? You know, if the questions, it mustn't cost any more than what we do now, then you get the cheap rubbish pads we have. If you say, right, here's our specification, we want X million tonnes of life out of it. We don't want to do any work on it during its life cycle, which is the new standard. So rather than just, because the concrete sleeper standard was just about concrete, it didn't have anything about shape in it.
More about how you test concrete.
Yeah, about how you test concrete,
Yeah.
So, and how you make pre-stressed concrete. Now it's a specification which is a performance spec, isn't it, for a sleeper?
It is,
So
yeah.
it's got to have this kind of lateral resistance, it's got to be able to take the rails, etc., etc.
I mean, the concrete sleeper gradually developed from the F-24s to the F-27s.
27, 28, 40.
They got a great stonking end plate to resist ballast movement,
Yeah,
and it got a sort of slightly delta shape to maintain it, to stop it coming up, but it couldn't go sideways,
Yeah.
it couldn't go laterally.
such it all.
It couldn't go anywhere, so that's why basically a concrete sleeper was quite successful with CWR.
So as you can see,
And we've replaced that with plastic, potentially with a hedgehog sleeper, where we're using the gravity effect of the ballast lying on top of the plastic
Exactly, yeah. Pressure.
in a delta shape,
Yeah,
foot to the base.
Yeah.
And we're using a wedge of ballast on top of it,
yeah.
base or flat up to the top to pull it all down.
What's happening at the moment is you've got a supplier for that, supplier for that. You've got no one that does both together. So we said, look, it's a system. Why aren't you? So we purchase up to £6 and we free issue them to Cemex and Troet Mold. They then stick them and glue them, fix them down. And we actually, we'd rather someone design that to work with their sleeper and their fastening system. So the fastening system, the USB, everything works together nice and harmoniously and it gets installed. Then they can adjust that to make it work rather than us go, there you go, is that compatible with your sleeper? Is that compatible? So at the moment, that is where people are starting to think. They're going, we might start designing a USB, we might start designing this as a wholesale system that they can supply to us rather than Pandrol gives the fast clear, Pandrol gives that, gets us the end sleeper pad, Sags gets concrete. So like 3 or 4 different suppliers in sleeper. And we'd rather that be all one.
we're starting the same thing with rail pads now, because there's a lot of people that come to us and said, look, the rail pads you buy at the moment are they're designed to be cheap. But if you want an engineered rail pad which is going to last the same life as your concrete sleeper, wouldn't do that.
Yeah.
That's a different question, isn't it?
So we do deal with the fastenings, and nuts and bolts and screws, ASCs, SSAs. I deal a bit of those as well, and variables and bits and bobs. So there's lots more improvements we can have in the fastening systems as well. And you're right, and there are better products out there, but some people want absolutely the most minimum viable, does the job, that'll do me. But then it's like, well, if you've got some problems, why don't you use this?
Yeah.
There is alternatives.
It's having
No,
the whole life
Yeah,
view on it, isn't it?
yeah.
So there seems to be no reason why the under-sleeper pad should last the same life as a concrete sleeper, for example.
And that's
what we're using now.
They've got to prove that, because some under sleeper pad suppliers, they've taken sleepers out after 30 years, it's gone, there's no under sleeper pad anymore. And some, it's still there. So in Europe, they've got 3 or 4 different suppliers, so there's a mixture. Whereas we've just got one at the moment, so we know what we've got. We've got one of the best that other people use as well, but it does last the length of the sleeper, which is what you need.
Yeah, I thought thinking about sticking back on it. Any more questions?
Darren, good one for me. Thank you very much. Just probably going into a bit of detail. The standard for sleepers that you're going to produce, I've noticed through the presentation, it talks about short ending your composites up to 250 millimetres.
Yes, yeah.
Product approval certificate, challenge, just curiosity, says 100 millimetres.
Yeah, you're right.
The standard 39 says 200 millimetres down to 50,
Yeah,
and 2102 says something slightly different.
for
So,
concrete, it's in 100. Yeah.
So
Yeah.
it would be nice that if they are doing that standard to get that sort of level of detail.
You're exactly right. A few people have picked that up. Yep, no, well spotted.
It's good for.
And, yeah.
I've checked it.
We had this, so we've got this issue where we've got 3 or 4 different composite sleeper suppliers like FFU, Sycar, so it's like, and then same with concrete. So concrete from Cemex, we can short end 250 mil, but from Troutwork Mole, long line, we can do 100 mil. So we've got differences in manufacturers. Some sleepers are good at short ending, some aren't, because they've got different manufacturing processes. So in that guidance document, I think it talks there about you can short end up to 250 to give people that guidance. But we didn't really want to provide. We didn't want people just to buy a whole load of 250 sleepers. I think that'll save you some money. But no, you're right. That PA certificate was due to be updated following some adjustments which Stan did, and that's one of the things we've changed. But for short ending for 250, it can be done. And then someone said both ends as well. Yeah, can be both ends as well. But what 2102 needs to do is it says it's for a minimum length of, and it doesn't say how many. So, whether it's 8 or 10, 12. So we need some more guidance on
Yeah, in combination with you.
get a whole length for a platform, short end. Yeah.
202, 39 and compliance certificate. The certificate for the sleeper.
The sleeper, yeah. Same on the declaration of conformities as well. That doesn't even mention it. Doesn't sub, yeah. And that's where 2102 needs updating about sleep. There's lots of things we picked up about sleepers in 2102 on some of the things we've been doing.
The Southampton workers also.
Yeah. I mean,
Put numbers to some of the things that are in there as well. So a bit more science to it, a bit more demonstrating why these things, because a lot of it was probably fairly empirical, if you like.
yeah.
Right, any more questions?
I'm on the property side, so mine really quite easy. So, materials, say we've had 1 or 2 sites where we've had to rent land to put material before it goes off site and they're doing the works. So I can remember one the last year or so. You asked the landowner if he'd like us to leave it there or spread it for it, all that sort of stuff.
Yeah.
So does all that go away to a certain extent? Because the number of, if you have to say Midwest, the number of lorries to take that across to a license.
Yeah.
Significant, all these. So is there going to be a big cost saving around that sort of area that we're not going to have to the material that either we're negotiating with people to what to do with it or
Is this where we've got a load of spoiled
Yeah.
land and we want to do some hard landscaping?
yes,
I know what you mean. Yeah.
So
Create some berms and stuff and just sort of spread it around. And
yes,
just,
there's our place.
Let it mix in.
Apparently, yeah.
no, because we would take it back to and reuse it. So unless you're doing it there, so we wouldn't be like we used to line side create these humps of ballast sometimes. If we didn't have enough wagons, we would then start discharging on site, wouldn't we? And our earthwaves colleagues would absolutely go, what have you done? You did that in our whole pile of, so, and
What does that mean? Then?
but we had to, we had to get rid of it somewhere because we ran out of wagons. So it had to go on the side, no, so for reuse, it will all go back to one aggregate handling depot, it will be controlled. And this is how it stands at the moment, so that wouldn't happen. But if someone wanted to say, do you know what we do is stockpile it and come get it later, you could do that because then they know there's a use. So it could be actually, maybe it's a project or you haven't got enough wagons or something's happened. Stockpile it aside, then we come back later and take it away.
Wagons are available.
Yeah.
Whatever.
Yeah.
We're losing sites of that side probably to be able to do that, really, but it's
Yeah.
worth thinking about.
And the other environmental issues, not issues, but there is that environmental, what are you actually putting there? Is that contaminated? What's actually in there last? So you can't just leave it there on my land.
No. And
Yeah.
with this one, anyway, it was sort of, it wasn't a green field, but
But
the question was,
semi-agricultural, was it?
no, this is it's like a yard.
All right, yeah.
Thing,
But
but there must have been a cost saving scheme for the question to have been asked.
Yeah, it's one.
So
That's fine. So if you find a user for it, some people would probably, bite your arm off for it. If they say, actually, I really want that in my,
Can I just, the last very last one, I did actually wait first, sorry, I do apologize. Then on the spoke switches that sell them at places like Bath, I actually remember there were big timbers at one point. Can it deal with that sort of?
so this product does,
Any shape or size?
this
Yeah,
product
because
does.
we're really using it for things like longitude.
Well, we're using it.
It's quite
That's
substantial.
what happened at Barmouth. Someone said there was a heritage,
Yeah.
did it have a heritage?
Yeah, it's listed.
It is, isn't it? So we had to do like timber.
Yeah.
It was, yeah, because that wasn't considered to be, although it looks very similar, and they painted to look like, I mean, that's paint. That's how it comes out. In fact, it comes out white. That's to stop the UV attacking paint. But yeah, I think it was for Barmouth. It was proposed,
Yeah.
but they had to keep it.
Cost-wise, it
And the cost
maybe
goes up, yeah, it's
would have
more
been-
expensive,
yeah.
but it will last as long, yeah. But so there are, I think more sites are going in FFU now than they are timber on longitudinal wear systems. It's just that particular one, it's a heritage site or, yeah.
Yeah, looking internationally, I mean, the Americans have been using these materials for a long time, and actually building structures with them. So.
Yeah, it's
using
got
the-
a element, you can build a bridge beam
Yeah,
out of it.
military particularly were quite keen because it's quite light and easy to handle, and you can saw it like wood and all the rest of it.
It's quite tricky if you're a structural engineer and you're sort of saying, I'm going to build a bridge out of this. You'd be like, oh, that's going back to some real serious, but they do it and they've done the same with Cycler. They built plastic bridge beams as well out of Cycler. And we've got different engineered composites, slightly engineered composite for a bridge, composite material.
Yeah.
But yeah, it takes a brave engineer to understand the performance of composites to do that sort of thing. But they do it. Okay.
Last question. Right, I'd like to call upon James to thank Virgin, thanks.
Yes, well, Darren, on behalf of us all, many thanks. It's been a very encouraging and an exciting presentation, really, because the challenge is huge for us, and we hear about changes that come along, aren't we, that don't necessarily have such a big impact. But this is huge, isn't it, in our industry, and not only change affecting us, but change affecting wider society. And it's been encouraging to see how the change, particularly with the sleepers, is coming about, that we're in some real proper thought going into the design and the testing of the sleepers and the whole life cycle as well. So not really looking so much at short-term costs, but looking over the whole life cycle of the sleepers. So if everyone could join me in the usual way, thanking Darren.
I'll close the meeting. Has everyone signed the sheet? Thanks.
Anything on there, Andy, guys?
Okay, our next meeting will be on the 6th of December.
9th, I think, yeah, 9th.
9th of December, yeah. What's on?
It's Mark Chestney, and he'll be talking about the, I need to speak to
SC measurement train?
you called it blue bubble train.
Bubble car.
Yeah, but he told me nobody calls it that.
I don't.
It's the not viaduct, visual inspection.
Units, yeah.
It's a class 153 that's been converted to,
It's using the very latest.
And it's painted blue.
it is blue, yeah.
Yeah, we are.
He said nobody calls it that.
So, yeah, and that should be fascinating talk, because that's, again, it's a really interesting application of AI. And it's pretty impressive the way it's developing. So that will be a good talk as well. Okay, so with that, I'll declare the meeting closed. Thank you very much. All
Yeah.
On the journey. On the journey for.
What's that?
Discussion was in the.
Yes.